Okay, so here we go talking about circles. And what a circle is just the set of all the points that are the same distance away from the center point in all different directions. So if you start with a particular point to be the center of your circle, and we'll use the letters H and K to stand for whatever the coordinates of that point are, and then we start for a particular distance away from that center point to be the radius of the circle, and then we take all the points that are r units away from HK in all different directions, that makes up the circle. So what would the equation of something like that be? Let's take a specific example. Suppose we want a circle where the center of the circle is the point 1, 4, and the radius of the circle is 9. So that means the circle is made up of points where for every point on the circle, the distance between that point, x, y, whatever those numbers are, and the center point, 1, 4, that distance has to be 9. Okay, so remember our distance formula. The distance between x, y, and 1, 4 should be the square root of x minus 1 squared plus y minus 4 squared. And we want that distance to equal 9. And we could just stop right there and say, okay, that equation defines that circle. But to make it look a little prettier, let's get rid of the radical sign by squaring both sides. The square root squared, squaring just undoes the square root, so then we have just x minus 1 squared plus y minus 4 squared. And meanwhile, we had to square the other side at the same time. 9 squared equals 81. So the equation for this circle would be x minus 1 squared plus y minus 4 squared equals 81. So notice how that's set up. We got one thing squared plus another thing squared equals a number. The first thing that's being squared has x minus the x coordinate of the center. The second thing that's being squared has y minus the y coordinate of the center. And then the number that they're equal to is the radius squared. It's the square of the radius. So in general, that gives you the standard form for the equation of a circle. It's x minus h squared plus y minus k squared equals r squared, where h and k stand for the x and y coordinates of the center point, and r stands for the radius. So let's try an example. Let's write an equation for the circle with radius 3 and center -1, 9. So we just take this x minus h squared plus y minus k squared equals r squared formula, and in place of h we put -1, in place of k we write 9, and in place of r we're going to put the number 3. So it's x minus -1 squared plus y minus 9 squared equals 3 squared. But I'm going to clean that up a little bit. Instead of writing minus -1, let me just simplify that to plus +1. So x plus 1 squared plus y minus 9 squared equals, and then instead of writing 3 squared, I just went ahead and wrote 9. So there's our equation for that circle. Notice it is in this form. And if you do see a plus instead of a minus, that just means you're dealing with a negative coordinate. Plus a positive is equivalent to minus a negative. So if you have x plus something, that's like x minus h, where h is a negative number. So what's the center and radius of the circle x squared plus y squared equals 25? We've actually seen that one before. Here, instead of x minus some other number being squared, it's just x by itself that's squared. It's x minus 0 squared. And you have a y minus 0 squared. So the center point of this circle is the point 0, 0. And then over here on the other side of the equal sign, where the r squared belongs, we have 25. So if r squared is 25, r must be the number that you square to get 25. That is the square root of 25, or 5. So this is the circle with its center at the origin and a radius of 5. And yes, we were looking at a graph of this circle earlier in this section, in the previous video. What about this next equation? The x-coordinate of the center is 2. The y-coordinate of the center is, notice this is a plus instead of a minus. We can think, if we want to think of this as y minus something, that something would have to be negative 5. So the center point has 2 for the x-coordinate and negative 5 for the y-coordinate. And then over here, in the place of r squared, we have the number 10. So if r squared is 10, r itself, the radius itself, would be the square root of 10, which is approximately 3.16. So the radius of this circle is a little bit more than 3. This particular circle is made up of all the points that are 3.16 something, a little more than 3 units away from 2, negative 5 in all different directions. And now that we know the center and the radius, if we wanted to draw that circle, I would start by finding where that center is. Here it is at 2, negative 5. The points on the circle are about 3.16, a little more than 3 units away from that in all different directions. So there's a point a little more than 3 units up, point a little more than 3 units down, a point a little more than 3 units to the right, a point a little more than 3 units to the left, and then all the other directions in between, all the way around, we can trace in the circle, and there it is. That's the graph of that equation. This last example is a bonus example because it is not in this standard form. X squared minus 6x plus y squared plus 2y equals 6 is not set up as something squared plus something else squared equals a number. But we can get it to be set up that way. Let me show you how that works. That's going to involve a technique known as completing the square. It's used sometimes for solving quadratic equations, but it's also used for rearranging an equation that you're trying to graph or get an idea what the graph looks like by putting it in a form that you're more used to seeing or that tells you right away what your center point or other things going on with the equation are. So here's what we'll do. Here's the equation, but I've left some spaces here. I've got x squared minus 6x. I put the two terms involving x together. Then I've got a little space here, and I've got y squared plus 2y, so the two terms involving y are together. And then that's equal to 6 on the other side. Now, to complete the square, that is to make the parts involving x a perfect square, it's got to fit this pattern where it starts with something squared, it ends with something squared, and in the middle it has 2 times the first thing times the second thing. So the trick to making this fit that pattern is if we've got an x squared here and then just an x term in the middle, look at the number in front of that x, take half of that, and then square it. And that's what goes here. So half of the minus 6 would be a minus 3. That's going to be like our b. And then we square that to get b squared, which is 9, and that's what I have to add in here. And it's perfectly legal to add 9 to one side of an equation as long as I add it to the other side at the same time. So I completed the square. I made this here a perfect square. This is going to factor into x minus 3 squared by adding 9 here and then also here to keep things balanced. Now look at the y's. We got y squared plus 2y plus, to complete the square here, what do I add? Look at the coefficient on y, take half of that and square it. Half of 2 would be 1, 1 squared would be 1, add 1 to both sides. So now the x squared minus 6x plus 9 factors into x minus 3, the quantity squared. And the y squared plus 2y plus 1 factors into y plus 1 squared. And over here we had a 6 plus a 9 plus a 1, which adds up to 16. So now this is in that standard form for the equation for a circle. So can you see what the center is? X minus h, so h is 3. Y minus k, so if we want to think of this as minus something, it would be minus negative 1. So the center is the point 3, negative 1. And over here, the number in the place of r squared is 16. So r itself would be 4. So this would be a circle with its center at 3, negative 1 and a radius of 4. If I want to graph that, find the center point at 3, negative 1, go, and yeah, I originally had this wrong. I had to go in and fix it, but the radius is 4, so we got to go 4 spaces up and down and right and left to get to points on the circle. For some reason, I originally had it as 2. So now this should show the correct graph where all the points on this circle are 4 units away from 3, negative 1 in all different directions. Start at 3, negative 1 and go up 4, down 4, 4 to the right, 4 to the left, and that same distance off at any angle, and you get to a point on the circle.